Hey guys, today we're going to look at some word problems using slope and y-intercept. So we just want to remember that slope is the change in y's over the change in x's, and the y-intercept is the value of y when x is 0, or our initial point. And then remember, slope-intercept form is y equals mx plus b. So let's look at the first one. It says Karen rented a bike, and after the second day it cost her $19. After the sixth day, it cost her $47. What is the rate of change for renting a bike each day? So I'm going to take this information and I'm going to try to make 2 points. So after the second day, it cost her $19. So that can be a coordinate right there. That can be a point. After the sixth day, it cost her $47. So there's another point. And then we just need to find the change in y over the change in x to find that rate of change or the slope. So I'm going to take my y2, which is right there, minus my y1, and divide by my change in x, which is 6 minus 2, which is, if I simplify that, it's going to give me 28 over 4, which is the same thing as 7. So the rate of change for renting a bike each day is 7. Then it asks us what the initial cost to rent the bike was. Well, if we know that at day 2 it was $19 and our rate of change is 7, then I'm going to subtract 7 2 times. So if I'm at 19 and I subtract 7, that's going to get me to how much it was at day 1. So 19 minus 7 is 12, right? And then we're going to subtract one more time to get us to day 0, which is going to be 5, right? So after 2 days it cost $19. If we backtrack to day 1, it would have cost $7 less, and then $7 less before that. So our initial cost, just the startup cost, would be $5. So we have those 2 bits of information, so now we can write an equation. We can say y equals, and usually we say mx plus b, but we know that our m, or our slope, is 7, and our initial cost was 5 over here, so it's going to be plus 5. Then if we want to find the total cost after a full week, which is 7 days, we're just going to plug in that 7 for x. So we've got y equals 7, x plus 5, but in this case our x is going to be 7 because it's 7 days. So 7 times 7 is 49, plus 5 gives us 54. All right, our next example says, during the summer, swimming pools lose water due to evaporation, which means water must be added back to the pool. At 9 p.m., the amount of water in the pool is 34 gallons, so that can be a point for us. So we've got 9 and 134. And then at midnight, there are 242 gallons, so that's a point as well. And I went ahead and put 12 because midnight happens at 12 a.m. So we want to find the rate of change for number of gallons of water being added. So again, we're going to find the change in y over change in x. So 242 minus 134, which we got right over here. Those are our y's, divided by our change in x, which is 12 minus 9. So we're going to end up getting 108 over 3 equals 36. So our rate of change is 36. So we're adding 36 gallons of water each hour. Then it says how many gallons of water were in the pool before water was added. Well, our first measurement was at 9 p.m. and they said there was 134 gallons. So our initial value is going to be 134 gallons. And write a linear equation to model this. So we know our slope is 36, our initial value, or the y-intercept, or b, is 134. So it's going to be y equals 36x plus 134. Then it says if water was continually added at the same rate, how much water would be in the pool at 2 a.m.? So there's a couple ways to do this. You could plug in, so if our first value was 9 o'clock, 2 o'clock comes 5 hours after that, so we could plug in a 5 for x. Or we could also count up from 2:42. So 2 a.m. is 2 hours after midnight, and our rate of change is 36. So if I do 242 plus 36 plus 36 again, I'm going to get 314. Okay, and that works the same way if we plug in 5 for x right there. Whichever way you prefer is totally fine. Okay, for the next one, this is a little drawing, so we're going to have to count those dots. So it says, assuming the pattern continues in the same way, how many dots will there be in figure 5? So in figure 1, there's 1 dot. In figure 2, there's 3 dots. In figure 3, there's 5. In figure 4, there's 7. So hopefully you figured out that we're adding 2 each time, okay? So assuming the pattern continues in figure 5, we should have 9 dots if we keep adding. So we should have 9 in figure 5. We're changing by 2 each time, so our rate of change is a positive 2. All right, and then it says to write an equation for the number of dots that would be in figure x. So an equation that we could figure out how many dots are in any number figure. So we know that our rate of change is 2, so we've got y equals 2x. But then we've got to figure out our initial value, or our y-intercept. And remember that y-intercept happens when the x value is 0. So we want to figure out how many dots there would be in figure 0. So if we work backwards, so going to the right, we're adding 2. If we go to the left, we're going to subtract 2. So 1 dot minus 2 dots, we would have negative 1 dots. So that's going to be our y-intercept. We had to work backwards for that one. So then we could just plug in any number. So like if I plugged in 1 for x, that'd be 2 times 1 is 2, minus 1 is 1, and that would tell us that in figure 1, there's 1 dot. We could do that all the way up to 100 dots and beyond. All right, the last problem we're going to look at is example 4. It says the bird is rising in the air. The height of the bird at 2 minutes was 640. So I'm going to make a little point there. The height of the bird, it's a hot bird. The height of the hot bird after 5 minutes was 930. So there's another point for us. It says the bird continues to rise in the air at the same rate. What is the height of the bird after 8 minutes? So the first thing we want to do always is find that rate of change, or the slope. So I'm going to find my change in y over change in x. So I'm going to subtract my y values and subtract my x values. Okay, and if I calculate that, I'm going to use a calculator. So I'm going to say 930 minus 640 is going to be 290 over 3, which is equal to 96.66. So we'll round that off there. And there's a couple ways to figure out the height of the bird at 8 minutes. So we have this information, and we also know that at 5 minutes, the bird was 930 inches in the air. So one way to do this would be to add 96.6 3 times, because we know that 8 minutes is, we're going to change 96 inches every minute, and the difference between 5 minutes and 8 minutes is 3 minutes. So I could say 930 plus 96.6 times 3, and that's going to give me 112.19.8. But there's another way to do this as well. I'm going to show you both ways because sometimes that number will be a lot bigger. So if it said like 20 minutes, we don't want to add 96 15 times. That's a lot. You could, but there's another way to do this. I'm going to do it in a different color. So we could generate our equation. So we know that y equals mx plus b is our y-intercept form. And if we just plug in what we know, so I could take 2 points. I could use either of these, but I'm going to take my y value and plug it in for y, so 640 is y. We found our slope to be 96.6. Then our x value of that point was 2. And then we can find our y-intercept, which will give us the equation. So if I do that and solve, I'm going to get my y-intercept to be, so I'll multiply 96.6 times 2, and I get 193.2 plus b equals 640. And then if we subtract that from 640, I get b equals 446.8. And then I can plug that in for b if I want to. Okay, so then I've got my equation. I've got y equals my slope plus my y-intercept. Oops, my bad. Okay, and then I can just plug 8 minutes in for x now. I can put that right there. I'll do it in another color. So we'll plug in 8 minutes right there. And that's going to give us the exact same answer. It's going to give us 1,219.8. So whichever way you like to do that is up to you, but I wanted to show you both ways just in case. So you can add the rate of change however many times we're changing, or you can plug in points to form an equation.